Hi, Mark Granis here with Lecture 6.1, The Three Kinds of Opposition. This is the beginning of Chapter 6 in our text, The Reasonable Person, and this is where we really get into the heart of how we use logic to expand our knowledge from things that we know to things that we don't know or didn't know that we would know. So let's get started. Today, we will go over equivalent and opposite propositions in general, because I want you to understand that there are equivalent propositions as well as opposite propositions. But then we're going to defer the equivalent propositions until a couple of lectures from now, because the opposites are actually easier for most people to work with. We'll talk about opposition in general, and then we'll talk about the three different kinds of opposition that we cover in section 6.1, contradictories, contraries, and subcontraries. And then we'll see how those fill in on our 2x2 matrix of A, E, I, and O. All right, so equivalent and opposite propositions. We know from what we've done in translation that there is often more than one way to say the same thing. There is, in fact, often more than one way to say the same thing, even when we're using standard logical form. For example, does it really matter whether we say some dogs are not friendly, which is an O proposition, versus some dogs are unfriendly, which is an I proposition? That probably doesn't matter very much. That's because we have negated, in one case, the copula, are not, and in the other case we've negated the predicate. We've made friendly into unfriendly. And there are some situations where that might not work, but here I think it works pretty well. And so these would be an example of something we'd call equivalent propositions. Equivalent propositions are propositions that differ in form but not in matter, and which must always carry the same truth value. So what do we mean by these things in red? Well, form refers to the quality or quantity of the proposition. That's what gives us the A, E, I, or O. But the matter is simply what the subject and the predicate are. And so with equivalent propositions, they differ in form but not in matter. They're always going to have the same subject and predicate, though they may be reversed, as we'll see in a little bit in section 6.3. But the key is that they must always have the same truth value. That is, either they're both going to be true or they're both going to be false. You'll never find a situation in which one equivalent proposition is true and its equivalent is false. That can't happen. By definition, that would not be equivalent. So why do we care about these? Well, equivalent propositions are really useful for extending knowledge, right? This is when we want to know what follows from what we already know. And the metaphor I've put here is that it's a bit like turning the cereal box upside down and shaking it to see if there's anything left. Like, you think you're out of knowledge, a question has been asked, you don't know the answer off the top of your head, but you wonder whether you can figure that answer out from anything else that you know. So you take another closer look at the propositions that you know, and you see whether anything in there implies anything. It's a little bit like working out a Sudoku puzzle, right? You look at a square, you know the square is blank, but do you know other things that could help you fill in the square? That's kind of what we're doing with equivalent propositions. We'll return to equivalent propositions later in section 6.3, but as I said, I want to start with the opposite propositions because virtually everyone finds the equivalent propositions a little bit more confusing. So we'll put those aside for now. Let's talk about opposition in general. We can define opposite propositions as any two propositions that respectively affirm and deny the same predicate of the same subject. Okay, so note that just like equivalent propositions, opposites have to have the same matter. They have to have the same subject and the same predicate, right? But they are going to respectively affirm and deny different things. So if I say all lawyers are crooks, that there are a couple of different ways that can be opposite. So all lawyers are crooks is the opposite of no lawyers are crooks, but all lawyers are crooks is also the opposite of some lawyers are not crooks. Both of those things are denials of what all lawyers are crooks affirms. In one case, it denies it of any lawyers, no lawyers are crooks, and in the other case, it says, no, they're not all crooks, some of them might not be, right? And note that one of these is much easier to prove than the other one. So figuring out what your range of opposition statements are is often very useful in practical terms for people who need to establish a point in an argument or in a legal case or something like that. All right. Opposites, though, are always going to differ in form because one affirms and one denies. That's what respectively means, which I know from experience is an unfamiliar word to many of the people watching this lecture. But when we say that two things respectively do one thing and the other, we don't mean that each one of them does both things. We mean one of them does one and one of them does the other. So in this case, for any two opposite propositions, one of them is going to affirm and one of them is going to deny. One of them is going to be on the affirmative side of our matrix, the A and I side, and one of them is going to be on the negative side of our matrix, the E and O side. All right. Now, a couple of things to note. First, all lawyers are crooks is not in opposition with some lawyers are saints, even though saints are not crooks, right? Because saints is not simply a negation of crooks. Saints and crooks, not the same predicate. And so though we have the same subject there, lawyers in both statements, we don't have the same predicate. So those two things can't be opposites. Similarly, all lawyers are crooks is not in opposition with no senators are crooks, even though most senators are lawyers, right? That's not the same subject. So unless you have the same subject and the same predicate, you do not have opposite propositions. All right, now let's look at the three different kinds of opposition that are covered in section 6.1. The first is contradictory propositions. And we can define contradictory propositions, or contradictories for short, as opposite propositions that differ in both quantity and quality. Okay, so first, they have to be opposite propositions. If they're not opposites, then they're not contradictories. And that means, accordingly, that they have to have the same subject and predicate. Contradictories are always going to have the same subject and predicate. All we're changing is the quantity and quality of the form of the statement. So, the contradictory of all logic tests are difficult. Well, that is an A proposition, and so we have to change its quantity and its quality. That means to change its quality, we'd move to our right to get to the E proposition, and to change its quantity, we would move down to the O, and then we've changed both. So the contradictory of all logic tests are difficult is going to be some logic tests are not difficult. In other words, it's the O proposition with the same subject and predicate. What's the contradictory of some animals are not amphibians? Well, that's an O proposition. We have to change its quality, which means we go over to the I, and we change its quantity, which means we go up to the A. So the contradictory of some animals are not amphibians is going to be all animals are amphibians. Note, I know that all animals are not, that the statement all animals are amphibians is false. I know that. It's still the right answer to the question of what is the contradictory of some animals are not amphibians. So one of the things to note about working with contradictories is that we're always going to be working with a pair of statements, one of which is true and one of which is false. If you never write a statement that's false as the contradictory of something, then you're going to get a lot of answers wrong, because in logic, we deal with all kinds of false statements. In fact, we can learn from false statements. So don't shy away from writing things like all animals are amphibians just because you know that that's a false statement. That's sometimes the right answer, even if it's a false statement. All right, let's do a couple more. Some snarks are boojums. Note that we don't have to know what snarks or boojums are to know that the contradictory of this is going to be that no snarks are boojums. That is, this is an I proposition. We will cross the quality line to get to O, and then we'll cross the quantity line to get up to E, and we'll have no snarks are boojums. What about no heffalumps are woozles? We'll cross the quantity line to get down to O, and we'll cross the quality line to get over to I, and we'll get some heffalumps are woozles. O always contradicts A and vice versa. O and A are a contradictory pair. I always contradicts E and vice versa. I and E are a contradictory pair. Well, so what? Here's so what. Contradictories have this useful and interesting property. which is that contradictories can never both be true or both be false, right? There's always going to be one of them that's true and one of them is false. And therefore, we can always find the truth of one contradictory by finding the truth of the other. And that is indeed a very useful and interesting property, because if you think about it, how can I know whether all lawyers are crooks? I couldn't possibly know that. I can't know all lawyers. But I can examine particulars. I can know about some lawyers. I can know that some are not. And if I know that some lawyers are not crooks, that is, that O proposition is true, then I must know that the statement that all lawyers are crooks, the A proposition, is false. Right? So that's what makes contradictories extremely, extremely useful. All right, let's go to the second kind of opposition, which is the contrary proposition. And we can define contrary propositions or contraries as opposite propositions that are both universal but differ in quality. Again, if they're not opposites, they're not contraries. So we've got to have the same subject and predicate here. But in this case, we're also never going to be in the bottom row of our chart, because the bottom row of the chart is for particular propositions, not universal propositions. And our definition here says that contrary propositions are always going to be universal. That is, they're always going to be A or E propositions. So, contrary of all lawyers are crooks, change the quality. All lawyers are crooks is an A proposition. If we change the quality, we get an E proposition. And therefore, no lawyers are crooks is the contrary of all lawyers are crooks. What about no heffalumps or woozles? Well, that's the E proposition. Let's change the quality. That gives us an A. All heffalumps are woozles. What about some animals are amphibians? Change the, wait a minute, that's a trick question. There is no contrary for some animals or amphibians, because that's in the particular row. I and O propositions have no contrary. So A and E are contraries. Well, so what? Contraries have this useful and interesting property. Contraries can both be false, but they can never both be true. Right? So it can be false that all lawyers are crooks and false that no lawyers are crooks. But it can never possibly be true that all lawyers are crooks and no lawyers are crooks. Those can't both be true, right? A and E, contraries, can't both be true, can both be false. And that means that if you can establish that one of those things is true, then you can establish the other is false. Note that much of the universe actually works this way. For example, if I were to say all dogs are friendly and no dogs are friendly, both of those things are false, right? Just like all lawyers are crooks and no lawyers are crooks, right? What does that mean? Some are and some aren't. And again, much of the universe works that way. All right, let's look at our third kind of opposition, the subcontrary proposition. Subcontrary propositions, or subcontraries for short, are opposite propositions that are both particular but differ in quality. Again, if they're not opposites, then they're not subcontraries. So we have to have the same subject and predicate. With all of these things, we must have the same subject and predicate. I hope I'm emphasizing that enough. But this time we're going to be in the top row of the chart, because we're going to be, we're never going to be in the top row of the chart, because the top row of the chart is for universal propositions. Subcontraries are always going to be both particular, right? So that means I and O. Subcontrary of some animals are amphibians, that's going to be some animals are not amphibians. What's the subcontrary of some monkeys are not literate? That's going to be some monkeys are literate. All we're doing is moving from the affirmative column to the negative column, or from the negative column to the affirmative column, always staying in that particular row. All boojums are snarks. That's the trick question again. That has no subcontrary because it's an A proposition. It's a universal proposition. A and E have no subcontraries. They're the contraries, and the I and O are the subcontraries. So note that means that the contrary relationship is at the top of our chart, A and E, and the subcontrary relationship The sub-contrary relationship is at the bottom of the chart. The sub-contrary is below the contrary. Interesting. Okay, well, so what? Well, contraries can both be true, but they can never both be false. What would it mean for both of them to be true? Well, we've seen some examples already. Some lawyers are crooks, some lawyers are not crooks, right? As I say, a lot of the world works that way, but they can never both be false. If it's not true that some men are immortal, then it must be true. If it's false that some men are immortal, then it can't be false that some men are not immortal, if you pardon the double negative there, okay? All right, so how did we fill in our matrix here? Here's how it looks. We have the contraries going between A and E. That's a contrary relationship. We have the subcontraries at the bottom between I and O. That's a subcontrary relationship. But the most contradictory thing, the most opposite thing that we have in the whole matrix so far anyway, is the contradictories. And we have two pairs of contradictory relationships. I and E are contradictory, and A and O are contradictory. And note that there's that great big X that's a little bit like the X that comes up when someone makes a bad guess on Family Feud. It's like, eh. Yeah, the X just means that is, if one of those is true, the other one is definitely false. Those two things can never have the same truth value. So we'll fill in a little bit more on the chart when I come back with section 6.2. Thanks.